So I'm just going to repeat a couple of the things that I just said. So yes, the other review session video has been posted on YouTube on like the 1002 YouTube account. Links to that are in Piazza um, under the announcement of the review session and also in some threads asking about the review session. I also made a parameters video, so make sure you check that out. So yeah, today we're going to be going over um, our questions. So I'm going to go ahead and share that with you all. So yeah, I'm hoping to get through the whole review. Make sure you guys are answering questions so we can get through this as quickly as possible so we can get through all of them. So yeah, let's get started. So the first one asks, well, actually, are there any questions before I continue about anything else?
Are we gonna go one by one for each question, or should we ask you questions?
So I will start with one. Actually, no, I'm going to start with 3 and 5. And then from there, let me know what order you want me to go in. Yeah, there are also TAs in the chat to clarify stuff. So feel free to add questions in the chat as well. But yeah, I'm going to start with 3 and 5. And then from there, just put the ones that you want me to do after. I will probably go through all of them. But yeah, besides 3 and 5, you can go ahead and put the ones you have questions for. Okay, so the first one that we're going to go over is 3. And so the question says, what data type would P be in a function definition that begins with def test function mn star p star star q? So any guesses for this one?
B.
Yeah, a tuple, right? So if you guys remember, whenever we have one star, that means, or whenever we have any star, that means it is a variable length parameter. If we see a single star, that is a variable length positional parameter. If we see double star, that is a keyword. There's a variable length keyword parameter, both mouthfuls. But if we see one star, this parameter basically means that everything that is added after the n will be a tuple. And for q, everything that is added after the values of p with a keyword will be stored in the dictionary. So star variables become tuples, star parameters, become dictionaries. Are there any questions with that? More about this also can be found in lecture 20. Also, again, I just made a video about it. I posted it about 3-ish hours ago, so that also might be helpful. But are there any questions about this one?
So then if we want to include more than one tuple, are we able to do that, or will it just take more than one tuple and a queue and a dictionary? Would that be possible? Or if we want to include a dictionary too, it means that it will only consider one tuple?
I see. So you can have several variable length positional parameters, which is the tuple one. And the same thing goes with the variable length keyword parameters. But you have to have them divided by something. So basically, like in this case, it works because we have two positional parameters here. And then we have a variable length positional here, and then a keyword one. And so if we were to, I'm just going to switch to my other screen just to show you all really quick. Oh, there we go. Okay, so we have our definition F, and we are taking in M, and I think the other one was called star P, and then star Q. and then I'm going to print M, and then N, and then P, and then Q. So I'm going to do all of them. You can do more than one sort of variable length positional parameter, but you have to be very specific as to where you place it. So let me show you. So when I run this function, and I'm going to give M the value of 1, N the value of 2, and then I'm going to put a bunch of 3s. And so all these 3s up to the word with a keyword will be stored inside of P. So if I put word 1 is equal to hello, for example, this one will be stored in Q because it contains a keyword, and therefore goes inside our variable length keyword parameter. Again, these are very long words, but basically it just goes into Q. And then I'm going to have, say, word 2, and I'm going to equal that to hi. So when I run that, you'll see that, I mean, the first two we sort of expected, right? So we expected M to be 1, we expected N to be 2, and then everything after those two will be stored in P, right? Because it can be any length. And same thing with Q. So now, what if I want to add a second one? So I'm going to call this W. And in order for this to work, I have to have sort of regular values after this. And so what that means is that, oops, just kidding. Wait, I don't know if just kidding. So I guess you cannot add this after. So they have to be in order. They have to go from positional, just basic positional parameters, then keyword parameters, then a variable length positional parameters, and then variable length keyword parameters. But yeah, that's a good question. I actually did not expect this. Does that answer your question?
Yes, thanks.
Mm-hmm.
Can you just explain? I kind of am still confused what a tuple is. I mean, I know the definition of it, but a tuple is always in parentheses. It is a list that doesn't get changed. Is that correct?
Yeah. So a couple of things about
in brackets.
tuples. You are right. They're very similar to list. But the difference is, the main and large difference is that they're immutable. So immutable means they cannot be changed without, basically it just cannot be changed. Another cool thing about tuples, and what makes it very similar to list, is that they're subscriptable, which means you can index them. And similar to a list, they can be any length. So really the main distinction is that you cannot change them. So for example, if I have X, if I have X and my X is a tuple of 1, 2, 3, and I try to do, for example, like X dot append 4, this is going to break because you cannot append anything to a tuple, or you cannot change the length of a tuple. So I can try append, I can try add, I can try a bunch of things, but none of them will work because you cannot change the length of a tuple. And it goes back to the fundamental idea that you cannot change the length because tuples are immutable, which means that once you make them, you cannot change them. Like anything, there are ways to get around this, right? So I could, in theory, for example, make a new tuple and save these values and add one more at the very end as I'm making it, but like that is not the same thing as changing. Whereas, for example, if this was a list, right, my list is X, and I can append a 4 to my list X.
So a tuple is always in parentheses then,
Yeah,
not ever.
tuple always in parentheses. They have like these little bracket or like these little, yeah, I mean they're parentheses, stuff in here. Very similar to lists with these couple of exceptions that they are immutable, they use parentheses instead. And yeah, those really are like the two main things. We really like tuples because they're very secure, because they're immutable. So that's sort of one of the reasons why, because I think like at first glance it might seem like, wait, why did the Python creators even make tuples? But the main reason is that it's because they're immutable and so they're safer than lists. Does that answer your question?
Thank you. Yes.
Mhm. Awesome. Are there any other questions about tuples or parameters?
Wait, when you made the function, like why didn't the asterisk W work?
Oh, this one?
Yeah.
If we had 1, 2, 3. So just for those who weren't here before, we originally had this, and so the question was, can we have a variable length positional parameter after we have a variable length keyword parameter? And so my guess as to why it didn't work is because this, like Python doesn't know when this ends type of thing. In theory, these are, actually, let me get rid of this, because I think this is actually, sorry. Yeah, so when we had this, basically Python is expecting keyword arguments. And so when we give it something that doesn't have a keyword, it errors out saying like, wait, you didn't account for W. I think it's just like a general rule that like I think if you have like a G, for example, yeah, no, I think it's just like the order and sort of the rule of like you have to go from positional parameters, then keyword parameters, then variable length positional, then variable length keyword. I do think that, I think earlier when I was playing around with like the video, and I think some of the examples that Professor Cannon gave, he got away with, I think, doing it if he had like a G and then W star. So basically if we had like another keyword parameter that did not belong to k-args, basically like indicating that k-args had ended. But I'm not sure if it's gonna work, but we can try it out. Let's see. Yeah, I think it's just like the order of it. Like you always want to go from positional to keyword to variable length positional, and then variable length keyword. And then within this, we can also have default values for those parameters, right? So I could say y is equal to 2 in here. And this would have to go, let's see where we at. So basically this would give, if we ran this again, we would see that y would be 3. Oh, I guess it would still work because I have this. Yeah, I think it's just the order that like Python requires you to have them.
So are you able to have like more than one variable length positional parameter? Like if you were to change the asterisk W and move it after star P.
Oh, I see. So if we did this one here, for example, is this what you mean, Jenny?
Yes, but then move like the asterisk P before the asterisk Q, and then move the star W after star P.
Oh, I see. So here and then star W here.
Mm-hmm.
Yeah, so this wouldn't work because variable length arguments, right, can take in as many arguments as you give them. So we wouldn't be able to tell the distinction of where one starts and where one begins. So for example, if this is what we have, your intention, I'm going to delete the y. Your intention might be to have m equal 1, n equal 2, and then have the first two threes go to P and the next three go to W, right? But Python doesn't know how to distinguish that because to Python, it just sees all these threes. And so this will break after this one because it will basically give everything to the P. And then it will be like, wait, what do I do with this W now?
Oh, I see. Thank you.
Mm-hmm. Yeah, and the same thing would be for putting two, oh, I guess the same thing would be for putting two variable length keyword parameters together. It doesn't know how to recognize like which pairs would go to Q and which pairs would go to like the next one. So if we call this say X. But yeah, the only thing that we can put in between these are basically default values, I would say. So if I wanted to do this and then I had age is equal to 2, this would work out. What do I have invalid syntax? Oh, I still have this. No, this should not. M N B star Q H equal to 3. Oh, yeah, no, I think you just can't. It just has to be in the order. Yeah, I think Professor Kennan had good examples about this, and I'm almost sure he had examples of that were like a little bit more moved around, but I can't think of any. If anybody has any ideas, let me know. But yeah. Are there any other questions?
There's a little bit of confusion in the chat about the differences between a set and tuple. Can we just go over that?
Yeah, so a set, so let's go over it down here. Actually, I'm gonna get a new cell. Okay, that's all runs. So sets are a bit different. For one, sets are mutable, which means they can change. And so what the definition of a set is it is an unordered collection of unique items. I'm pretty sure I misspelled. There we go. Okay. So yeah, it is an ordered collection of unique items, but sets can be changed. So I guess like the main difference between sets and tuples is one, the way that you sort of have an empty tuple looks like this. So it looks like a tuple. I mean, this would be a keyword, so I'm going to call it tup is equal to just brackets. And the way that you would make an empty set would be empty set brackets. And then when you print out a set, so let's say I have my list. I'm going to start off with a list just so you all can see for both of them. So I'm going to start off a list for this, and then I'm going to print tuple of x, and then I'm going to do the same thing for set, but instead of making it a tuple, I'm going to make it a set. So when I run this, let me comment this stuff out. So when I run this, you'll see that it will be like parentheses 1, 2, 3, and this one will be curly bracket 1, 2, 3. A tuple, likewise, if I have repeats in here, will not care if I have a repeat, so it will take in that repeat and embrace it. And sets only want unique items. So a set will tell you, no, I want unique things, and it will get rid of that 3. Are there any other questions?
Can you show us like adding or removing things from sets versus tuples?
Yeah, so I can add to a set x dot add by doing x dot add. So if I wanted to add 7, let's print out print x. Oops. Let's see, why does it say? Okay, so I have to actually make this a set first. So basically here I'm printing out the set, but I'm not saving it anywhere, right? So let's save x set is equal to set of x. And once I have done that, I'm going to do x set dot add and then print that out. Invalid syntax. Oops, I'm missing a bracket. And there we go. So you can add to a set by doing dot add. Whereas because tuples are immutable, you cannot add anything to a tuple. So we can do dot add, dot append. You can try them all. There's just no way because tuples are immutable. If you really are set on making a tuple with whatever you wanted, you would basically have to make a new tuple to it. So a way that you can do that is do like for I in, I'm gonna call this x tuple, where this is gonna be a tuple of x. And so I would have to go through my whole tuple, add this to a list. So I'm gonna have my empty list L, and I would do L dot append I, and then after I do that, I can do print tuple of L. But this is very different than just doing dot add, right? So in here, I am making a whole new list and making a whole new tuple, which is not the same thing as just adding something to it, right? So if you wanted to make a tuple with an extra item, you would have to make a whole new tuple. Again, because tuples cannot be changed, whereas sets can be, things can be added from them, things can be removed from them, and so on. Is everyone okay with that, or are there any questions?
Just one more question. So tuples are in parentheses, lists are in brackets, and sets are in curly brackets. Is that correct?
Yes.
And then,
yeah.
Sorry, go ahead.
I don't know, go for it, Heather.
And then what is unordered? What is that? What do you mean?
Yeah, so unordered means that there is no order to them. So if I were, like it doesn't get sorted, it's just like a random order. That's all unordered is. I think Jupyter, in one of my previous sessions, Jupyter's kind of weird because sometimes it will sort it, in this case it's sorted, right? But if I put it in here, it should just be like in a random order. And I mean, it is. Like it's just like a random order. That's what unordered means. There's no order to them. Like they're not in like alphabetical order or anything like that. It's just literally random.
But tuples puts it in order. It sorts it.
No, tuples also just leave it the same. So tuples are also unordered. But I guess like the difference is, yeah, so Gabriel made a good point. Not order means you can't index it. So if I try to index this, this will basically say no because sets are not subscriptable / like they cannot be indexed. And so the reason why they cannot be indexed is because they are unordered. So for example, tuples, the order matters, right? Because if I want to index a tuple at 0 because I want to grab that 1, I know that if I index it at 0, I'm going to get that 1. Whereas sets, if I try to index something at 0, because they are unordered, they are not you're not able to index them. I was trying to make up a word that didn't exist. Yeah, does that make sense?
Yes.
Yeah, so basically like the fact that you can't index them is because they are unordered.
I get it now. So a list, it could be in any order, but that's the order that it is, which is why you can index them. But set, it could be any, it just grabs it. Okay, like
Yeah, exactly. It just grabs it. I even think that if I like print this out several times, just kidding, I guess not. I was like, maybe it'll give me different orders. But yeah, it's just like an unexpected order. It just gives it whatever. Are there any other questions about this? Cool. So now I am going to go over number 5. So for those of you who just joined, I'm going over questions just based on how they're added to the chat. I'm hoping to be able to get through all of them. So overall, we should still be good. But yeah, so I think, is that one the machine learning one? Oh, just kidding. Okay, yeah. So this one says, a major advantage of using the with expression versus other approaches when reading and writing text files in Python is, are there any guesses?
Well, I know that you don't have to close it when you use the with, but I was wondering about B because isn't it more efficient also? That's what I read about it, but then I don't know how to answer that question.
So it is more efficient than opening a file using the built-in open function. So the main thing here, I guess like if I was in your place taking this test, it wouldn't be all of the above because we never talked about older programming languages, and we never talked about like moving inside of the file backwards or anything like that, right? So I'm not sure if it is more efficient than other methods, but I know for a fact, right, that with is really helpful because it will automatically close the file for you. So the correct answer for this one should be A. But yeah, I think like if it is more efficient and that's what you read, I think this specific answer would be A because like the other two don't make sense. Like all of the above would not make sense. But yeah, the major advantage of using with is that the file automatically closes. So if you were to instead like call read lines or something, or not read lines. If you called, what was the other one? Can somebody remind me what the other one was that was not with open?
Just open.
Yeah,
Open
just
file.
open, right?
Open file. Yeah.
Yeah, so if you just open a file normally, that requires you to have to close it at the very end. So you would do like f.close if you guys remember. So yeah, the main advantage is just it automatically closes, even if it fails, right? So cool thing with the cool thing with open is that even if like something goes wrong, the file will close. Um, so yeah. Are there any questions about this?
Yes, I'm sorry. Could you please go over 5? I didn't understand.
Yeah, so there are different ways to open a file. The first, and like the one that I think you all mainly use, was with open. So I don't have a file with me, so I cannot show you all how to open a file. But what it looks like would be like with open, and then file name .txt, comma, and then the way that you would be opening that file. So this could either be reading, writing. Really, reading and writing are the only ways that we learned. For the most part, we would use the R. And so what that does is that in here, this will basically open the file, and then you can start reading from there, right? And so I would put some code in here. And then from there, when I want to print, I don't know, say I made a list of, let's say, I made a list which I appended every line to. Up out here, I could just print my whole list, and so I don't have to close the file. Whereas if I used file dot, I think, is it called file iOS or sorry, I'm just trying to remember what it was called. I think it was just open, right? Can
File
somebody?
equal open, then
Yeah,
a
right.
file name with R, write something. Yeah.
Yeah. So for example, in this case, right, if I were to open this file like this, again, this also takes in either the reading, the writing, so on and so forth. I would put my some code here, and or for example, if I wanted to do the same thing as above, I would probably do a for loop. And then inside of my for loop, I would put some code, probably like file dot read line or something like that. And then at the very end, I would have to call file dot close. And
I
so
just didn't understand the 5 because he gave like an answer you can move from place to place in the file, including backwards, and I don't remember learning that.
yeah, that's why it's not that one. So the answer for 5 would be B.
Would be what?
B.
Oh, okay.
You mean A?
I'm
A.
sorry, A. Sorry. Yes. Yeah, thank you. Yeah, so the answer would be A. So what I was saying was that you know that it couldn't be E because we've never learned about, it being similar to older programming languages. And like you said, right, he's never talked about like all of a sudden being able to read a file backwards. So you know it couldn't be C and D. And then what Heather was saying was that she read online that like B could possibly be it because it's a bit more efficient than the regular open. But because these two cannot be it, then you know that it has to be A because A is the obvious answer in comparison to like all of the above. Does that make sense, Melanie?
But B is also correct?
No, so I'm not sure about B. It was just something that Heather found online, but because we didn't cover it in class, we didn't cover it in class, so he wouldn't expect you to know this. I also don't know if it's true or not. I'm just going based off of what Heather is saying, and I like believe her that it's probably more efficient because it automatically closed it. But like the obvious answer and like the one that is most correct is A.
Thank you.
Mhm.
Yeah, I
Yeah.
hope this one is confirmed by professor, because in case the real test have those questions, it may end up in B the right answer.
Yeah, I mean, you're welcome to ask him, right?
Okay.
But
Yeah, because I noticed you can open 2 files at the same time with open. You can open multiple files. And of course, you don't have to close. It shows a little bit more efficient.
so I guess like the key word in this one, right, is major advantage.
Okay, yeah, major, that's true.
Yeah. So like that's another thing, right? Like if B is another one, we want the major advantage, right? And so
Yeah,
although
that should be right.
opening a bunch of files, I mean, you could in theory also, yeah, I guess like if you used open, um, you could in theory do the same thing, right? So if I wanted to do several files, I would just call them differently. So I could do file 1, file 2, so on and so forth. But it wouldn't be as good as with open. Yeah, I would just focus on like major advantage, right?
Yeah, I got a major advantage.
Mhm. Are there any other questions about this one?
Wait, does that mean that you can't like open 2 files with open?
So from my understanding, with open opens the file just like based on how the text is added. It opens one file at a time. So if I had with open part 2, then this would basically open this, do this in here, and then go on to the next one. Do this in here, and go on to the next one. On like the fundamental, like sort of computational level, I think that Python might have some optimization and be running things at the same time. So it like running if basically like if things are not related to each other and don't affect each other, then they can be run in parallel, which means that they can be run at the same time. So my guess is that with open has something similar to that. So if this stuff is not affecting anything in here, they can run in parallel. If there is something related to it, then the first one would run and then the second one would run. But again, that's like getting a lot more nitty gritty than for our purposes. So the answer, I guess, is it depends. If there is something that affects something in here from the previous one, then they won't run at the same time. They will run one at a time. If it doesn't affect it, I believe that Python will optimize for it and run both of them at the same time. But again, this is getting a lot more specific than what we need to know.
Yeah, I was just wondering the difference between with open and open. Like, is the only difference that with open it closes the file?
Yeah, basically, that's
Okay.
really the most important one.
Yeah, I read the web. It says with open the file, you can directly give a very short file name. With open file, this name as A and a comma, and open another file as B. You put on the same line. That really make the code very efficient. You don't have to have many lines.
Oh, for with open?
Yeah, I can send you this on the chart. Okay.
Yeah, thank you so much. I appreciate that. Yeah, so that's a good point, right? So with when you open a file, all that is happening is you're just literally opening it, right? Whereas when you, so I'm gonna open this in here. Oh, what is it saying? Honestly. Mm. Oh, sorry. I think. Oh, I see. Yeah, so you can actually put them in the same line in here, is what I guess Pranjali was saying. Um, yeah, I think for like our purposes, he, let's see. Yep. Sorry, I'm looking at the chat. Um, yeah, I think for like our purposes, the main two things is one closes a file, one doesn't close the file, and not closing a file is actually terrible because it's basically going to stay open for as long as your program runs, and that just makes it super inefficient. That doesn't mean necessarily width is more efficient under the hood. Yeah, I think Python is like a super, at this point, like Python has a lot of optimizations it does under. Um, so really like, I'm not 100% sure which one, like if we ran it, I think both of them would run differently in different scenarios. So open might be better for like smaller files, whereas with open, or actually the other way around, I'm not sure. But I think it just depends in the scenario that you use it. Again, sort of for this question, the major advantage is that with open automatically closes the file. Are there any other questions about this? So things you should know how to do for this test. Oh, sorry. Yeah. Sorry, was somebody saying something?
Sorry, so is
Mhm.
yeah, is there a reason why there would be situations where it's advantageous to use open instead of with open?
Um, let's see. So I think honestly that just open came before with open. But let's see. Use open. Trying to think of like a scenario.
It's really okay. I was just curious.
I guess one thing that could be is that I like essentially like with open it's just safer. So we are saying that like closing the file is something that is more efficient for us because we don't want to leave it open for extra time. But even outside of that, it's the safe thing to do, right? So if we leave our file open for more time than we want it to be, that sort of opens up the possibility of like someone reading from your file. So it could also be like the security purposes. But yeah, Pranjali is saying that most articles don't address the efficiency comparison. So I guess like efficiency is not even, I guess when I'm saying like it closes a file, it just basically makes it easier for you, right? That it closes the file. And it's an extra step that you don't have to do. But it doesn't necessarily mean that like it will run faster. So I guess the main advantage of it is it does something that if you forget, you are good. And the second would be if you were to forget this thing, it's like a security issue. Because like obviously we haven't learned about this, but if your file is open, that means that people can tap into your file. It's just not you tapping into it. Other people can also tap into it if your file remains open. So I guess like a main scenario where you would want to use with open would be like in scenarios where like security matters. So yeah, but I don't know if I have a better answer than that. Does that make sense, Ariana?
Yeah, thank you. I appreciate it.
Are there any other questions about this? Cool, so we're gonna keep going because yikes, we're already at 10:50. That time just flies. Somebody asked for 2, but they're gone. So I'm gonna go on to the next person who was here and asked a question. Okay, so Ariel asked for question 1. So for question 1, it says, what would the value of list B -1 be after execution of the following code? So even before we look at this code, just remember that like if we see a -1 in brackets for a list, we know that that is going to be grabbing the last element of list B, right? So whatever this is going to be doing, we know that we're going to be grabbing the last element of list B. Also, if you all are sending me private messages, I can't see them just because I'm just on this page. So if you guys have questions, let Paranjali and Edna know. So now here we have list A. So in list A, there are 3 elements. The first is 3, the second is 6, and then we have 4 and 2, right? Where 4 and 2 is a list. And then we have list B, and then it says list A, bracket, colon, bracket, right? Does anybody remember what this does?
Copy.
Yeah, it makes a copy, right? So what this is doing is this is basically making a copy of list A and equaling it to list B. So now, when you do list A dot append 0, that is going to change list A, right? But does that mean that our list B gets changed as well? Any guesses?
No,
Yeah.
because it's a
Not on
copy.
this situation, but in our midterm situation, it will be changed.
So in this situation, it would not change B because B is a copy of A, right? So B will be 3, 6, list of 4, 2. And if we append 0 to A, then A would change, but not B, because again, we made a copy of A. So this is no longer A. So B is not A. B is its own copy of A. So the correct answer for this one should be C.
But if the appended 0 was inside the second element in list A, then it would affect list B, right?
Sorry, if append was,
Like if list A became 3, 6, 4, 2, 0 all in one bracket, then that would change list B.
yeah, so if I were to move this append statement here in the middle between list A and list B, then list B would change because you're making a copy after you've added it.
I think also like our midterm, if you put list A bracket 2, no, the third line,
Here?
no, third one.
Okay, here.
Yeah, list A bracket 2, append 0, it will be changed. List A, you say bracket 2, like our midterm. You remember midterm question 17?
No, so that wouldn't be the same. So you're saying list
A, yeah,
bracket.
with a bracket 2.
Oh, I see. Dot append. Okay, so you're saying,
Yeah, that way it changes 4 to 0, right? Because this is only one layer shallow copy, it's not deep copy, right?
so no, not quite. So I see what you're saying. So what Lance saying is that if you have this, right? So this is the original one that we have, right? So we are going to print here. We want print list of B. And I'll go over this quickly because we need to move it along. What Lorenzo's saying is that if I did list of A at 2, which would basically be grabbing this little list, and I did append 0, this would change. And so why would it change, Lorenzo? That was a good catch.
Yeah, that's question 17 in the midterm.
Yeah, so this would, yikes, this was a good call out. Okay.
Yeah.
So the reason, I guess, like, if you don't get this, don't listen to me, turn off your ears. Again, I think this is probably a little bit more complicated. I think question 17 was, question 17 in the midterm, I think was a little bit different. But what this is saying is that we made a shallow copy of A. And what a shallow copy is that we basically just grab the elements in here and copy them in here. But these elements themselves point to something in like the memory space, right? And this, whatever this is pointing to, is going to basically be the same thing that the copy is going to be pointing to. So if I change something in here, then this will change. So let's see, what could be another example of it? It's just basically saying like all these reference something. And if you change it, it will also change the second one. Again, I really think that this is more than what you have to know for the test. I think if he were to give you something, it would be more along the lines of like list A is this, and then if you do list B is equal to list A, and then you do list A dot append 0, what would list B be? I think this is something more like what he will ask you, and what he, like, I think he expects you to know the difference between this one, not this one without the append stuff with the at 2. I think he wants you more to know the difference about this and this rather than like the super itty nitty stuff of adding this. But yeah, if you guys want to learn more, this is called a shallow copy, and there is such thing as a deep copy. And so if you were to do, I believe it's list A dot deep copy, this is a different type of copy that it makes. And it's, yeah, I don't think that's what it's called. I don't remember exactly what it's called, but it's, if you Google Python deep copy, a method will pop up for you. But yeah, are there any other questions about this? Again, I think that was a really good call out, Lorenzo. But yeah, it's important to know, but I think not as important as knowing the distinction between this one and this one.
In Lorenzo's case, does it change because the copy points to every single element and the third element changed?
Exactly, yeah. So basically we have list A, right? And so list A is pointing to A3, A6, and then a list of 4, 2, right? And so when you make a list B, it is making a copy of it. So it is making a copy of these things, but these are still pointing to the same things, right? Which is different than saying list A is pointing to, sorry, list B is pointing to list A, right? So if I wish I had like a something to, oh wait, actually, I do have something to draw. Okay, please excuse my really ugly drawing now. So now, if I have, when I do this, list B is equal to list A, what I'm essentially saying is that B is going to point to list A. And so that means that any changes I make into list A are going to be reflected on list B. But now, if I have list A This would be the case that Lorenzo brought up. If I have list A like this, and I make a shallow copy of it, what that is doing is this is going to make a copy of the same things, right? But the problem is that the individual things inside of this list are still pointing back to list A. So it did make a copy, but the individual elements are determined by this. And so what I was saying by making a deep copy, so again, if you Google Python deep copy, it will tell you exactly how to do it. But if you were to do a deep copy, what that does is it takes into consideration everything. So it takes into consideration the whole list and also the individual elements of it. So that is why like it would change.
Shallow copy, the reason why it would change the last zero is it because lists are mutable, and if you change like you put a zero as the first one, if you change the 3 to a 0, then the shallow copy would not follow because strings are immutable.
So if I did like, is this what you mean? And then I did, sorry, let me know if this is what you mean. So if I did is equal to 3, like this.
I mean exactly the same as Lorenzo's example, but the difference would be that instead of like appending to the last item, you would change the first item such that you're not appending to a list, but you're changing a string.
I see what you do. I see what you're saying. So you're basically saying like the fact that a list is mutable allows us to change that list. Whereas like in this case, we couldn't change, like we changed the number, but that didn't change the output. Is that what you mean?
Yes, I guess would the same result as Lorenzo pointed to work if that last thing was not a list but was a string?
Oh, I see. So if this was like this. So I actually think this would not work because strings are immutable. But let's make sure. Oh, I was wrong. Just kidding. Wait, no. Yeah, it didn't change. Wait, did it change? Let's see.
Within brackets to the last item.
Oops. Yes. So there's 2 dot append. Okay, so I guess it wouldn't work with append because we can't append to a string. I guess we could concatenate to it. Yeah, that's a good question. I'm not 100% sure. I think it wouldn't, but I'd honestly have to look more into it just to give you like a super clear answer.
Okay, thanks.
Yeah. Are there any other questions about this? Okay, cool. So now we're gonna go over 8. We will be ending at 11:30, so just a heads up. So I'm gonna delete my annotations really quick. Cool. So now let's go to 8. So 8 says a 2-dimensional data structure with columns of potentially different types most accurately describe which of the following. So any guesses for this one?
A.
Yeah, so for this one, the correct answer would be a data frame. And the reason why it would be a data frame is because series have to be the same type, right? So recall, series are a single column, basically, of a data frame. Same thing with numpy arrays. Numpy arrays have to be the same type. And for Python function and Python module, that just like doesn't make sense. Yeah, so for this one, the correct answer would be data frame.
Can you
Any
explain
other-
why it's not NumPy array?
Why it's not NumPy array?
Yeah.
So it's not a NumPy array because NumPy arrays have to be the same type. So you are right. It could be, I
How
mean,
do
a
you
numpy arrays can also be one-dimensional, right? So that would be another thing.
But what does type mean exactly here?
What is what, sorry?
What does type mean?
So a type would be like a type string, type. So what it means is like, what it's saying is a two-dimensional data structure with columns of potentially different types. And so what that means is that different columns are different types. So for example, if I had a numpy array with a column that was numbers, another column that was strings, another column that was booleans, and so on and so forth. And so in a numpy array, you can't have different types. You can only have a single type. Whereas like a data frame, right? We can have a column that, let's say we have like a data frame that has everyone's names in one column and then everyone's age, right? So the first column would be your name, the second column would be your age, the third column could be your favorite phrase or something, and so on. So yeah, does that make sense?
Yes, thank you.
Sorry, what do you mean by bumpy?
No, that was a typo. That was a typo.
Oh, okay, got it. Yeah, any other questions about 8? Cool, so we're gonna go on to the next one. So the next one that people asked for was 6. So K nearest neighbors as we start in class was used for, in this case, the correct answer would be classification. If you all did more research on this, you might have found an answer that said that it could also be regression, which is not wrong, but the way that you all went over it in class, Professor Cannon only mentioned it as a classifier. So for this case, the correct answer would be classification. Again, I think this is sort of the question that he would be more specific on. I don't, like he would give you something more yes or no for this one, because I think this one, regression and classification could be possible answers. But the correct answer is classifications because it says as we saw it in class. And so for this one, if you want to learn more about it, it's in the very last lecture that he had, which I believe was 21. But the Jupyter notebook file is called like ML1 or something like that. So yeah, 22. Thanks, Lawrence. Also, sorry, Lawrence, I've been calling you Lawrence. I don't know why I saw now. Yeah, thanks, Lawrence. Any other questions? Cool. So we're gonna go on to 7. I think, let me make sure that's the one that people wanted. Yeah, I'm pretty sure I saw 7. So 7 says, suppose you are given a data set of 100 labeled observations. If you use a data set, this data set in 5-fold cross validation, how many times will each observation be used as part of the training data? So can anyone, what did people think this was? I have my answer.
Is it 4 times?
Yeah, it is 4 times. So again, this is in the same lecture as the question above. But if you guys read a little bit about the 5-fold cross validation, what that is it basically divides your data set into k folds. In this case, it would be 5. And what it does is that it takes turns having one of them be the test and the remaining 4 being the training data. And so with this in mind, that means that one observation, so what it means by like will each observation be used as part of the training data, what that means is like how many times will one chunk be used as part of the training data. So the first time around, let's assume it will be used as the testing data. The second time around, it would be a training data. The third time around, training data, and the fourth time around, training data, and the fifth time around, training data. So the correct answer would be 4 times. And the reason why it would be 4 times is because those 4 times, the other ones, so basically like its brothers and sisters, the other observations would be the test data. And,
Liana, your microphone is making a lot of noise.
oh, I'm so sorry, my computer is, I think it's because I'm moving my computer. Is this better?
Yeah.
Okay, yeah, I'll stop moving it. Are there any other questions?
Sorry, the first time, what is that called? And the next ones are training?
Your test data. So basically, if we like divided our data set into 5 chunks, so let's call this chunk, we're gonna call our whole data set all. And so from all, we're gonna divide all by 5. And from there, we're gonna get chunk 1 all the way to chunk 5, right? I'm calling it chunks, but you can also call them observations. But I like to think about them in chunks. And so the first time around, chunk 1 would be the test data, and the other ones, right? So chunk 2 to 5 would be training data. And then I would basically do the same thing, but now instead of chunk 1 being the test data, chunk 2 would be it. And so chunk 1 through 3 would be the training data set. And so it's basically asking like, how many times will each chunk be training data? And the answer is just 4, because it's going to be the testing data once. And we are going to do this times 5. So we already have 2. So basically 3 more times we would do this. Are there any other questions about that?
Can you just clarify what happens differently in the training period versus the testing one? I didn't understand that when he explained it.
Yeah, so basically like it's not as much like what happens to the data itself, but rather more like how is it used, right? So with training data, so if you remember, there are 2 types, right, of machine learning. One is called unsupervised machine learning, and the other is called supervised machine learning, right? So unsupervised does not have a training data, and so that means that there's nothing to compare. Sorry, it doesn't have like it basically doesn't have data that is similar to what we should expect. So for example, like if we were, I know like long back in my day, I made like a, for a class, made like a machine learning thing that would decide between white wine and red wine. And so for unsupervised learning, it would basically be like, we're not giving it extra information about what a white wine should look like and what a red wine should look like. Whereas supervised machine learning is given a training data set, and then it is compared to the testing data set. And so it's more like of a how is one used than just like what are we doing to it, I think. So I don't know, I'm trying to think of like a good example. Yeah, I think it's just like the training data is used to train the algorithm, and the testing data is to determine how accurate it was.
So they will look the same like they will have the same code, just they're ones used as the example and the rest will adjust according to what the example is, the example that's given, like that?
Oh, I see. So, okay. So, when you're like running this, so let's see if you can see. I don't think you can see my screen. But if you go to your notes on the machine learning stuff, um, basically like all this stuff, as at least like when we're talking code, um, there are modules that exist to to like run these specific algorithms. So let's take like k-neighbors for example, right? And so we can give it, we can basically feed our algorithm values so that it can predict things, right? So that is what the training data would be. The training data is just sort of to test out, like basically what it is you are going to give your classifier training data. And I'm going to give this training data. And after it is done training based on this algorithm, which I guess like in our case would be like the cross validation, or you after you give it this data to train on, then it is going to use the testing data to see how accurate it actually is. And so if we are doing 5 folds of this, if we're doing this 5 times, the idea is that hopefully it will get smarter as it goes, right? And the reason why we want to do like the k-fold cross validation is because we will have used all of our data as both testing and training, right? So everyone gets a chance to be the data that is determining how accurate the algorithm is, and everyone gets a chance to train the data as well. Let me know if I went on a small tangent or if that answered your question.
Well, no, that does, but then, so then I guess my next question is then if you have a classifier and then all the training chunks are to see how close they are to that example and they
Yeah.
get smarter with each one, then why is the next chunk then become the classifier? Like I could see if you only had one classifier and like that, this is the example. And so
Oh,
we're going to see.
the testing data. So why does the next chunk become the testing data?
Yeah.
Next time around?
Yes.
Yeah.
Yeah.
So the reason for that is because maybe like in my data, there is a chunk that is like all, let's say that we were looking for is something a 0 or a 1, right? I don't know what I'm what I'm looking for, but let's just say that my final answer was either a 0, a yes, or a no. So we want to switch them all around because my first chunk might be all no's, right? And that doesn't necessarily mean that I will always get a no whatever I input into it, right? And so the more variety that we have and the bigger sample, the better we are. I don't know if that answered your question though.
Sort of. I guess I have to think about it some more.
Yeah, I think I might not be grabbing a question, but yeah, feel free to post it on Piazza too, and I can come up, I think, with something that I don't think I'm quite getting the question, which is the issue. Pranjali or Edna, do you want to repeat your question?
Yeah, so if in this case, like in question 7, if each, so we have testing and we have training. So if the testing data, so in of those two things, those two categories, what is the example that was, so is this supervised, or I guess maybe this is my problem. This is supervised, right?
Yeah, this is supervised because we have data to train and to test.
Okay, and unsupervised would be no training?
Yes.
Okay. So it was unsupervised, you would just have, you would just, you would have an example of what you want and you just try to get it to be like that, to see how close it is to the example?
Exactly, yeah.
Oh, okay, so
So,
then,
so one, you know what you have to get to, and you know what you have to get to, and you have data to train it on, right?
Yeah, and so in that example, he wouldn't even have the data set of 100 labeled observations.
Mm-hmm.
because you have the example of what you want, but with supervised, you aren't sure, so that's why each chunk it has to be the testing, has a chance to be the testing while the others train on it.
Yeah, so I guess like a machine learning person would yell at me, but like basically supervised learning is like you have training data to go based off of. Um, and unsupervised learning is like, well, I don't have training data, but I know what my final answer is supposed to be, so I'm just gonna guess at it until I figure it out.
Okay, that makes sense to me. The unsupervised training data that makes a lot of sense to me. The supervised one doesn't make as much sense because I guess I don't understand how it's
So
going to
inside of
improve.
the training, what happens is that like there are also checks inside of the training. And so like I am making I guess like machine learning for the most part is like a bunch of really educated guesses, right? So if I have my training data set, the first time around, I'm going to guess it's a no based on this criteria. If I get that wrong, then next time around, I might get something different. I might guess something different. And then next time around, I'm going to get something different, something else, something else, something else, right? And so the idea of it is that you're using this training data to train yourself being the algorithm, um, to make better guesses every time. And then at the very end, you run one final run with the test data. And the test data is basically just like, okay, let's see, now that you've had all that training data and all that practice time, let's see how many you accurately guessed. Right? So there are like checks inside of the training phase. Like the training phase is essentially like, I'm going to grab this first observation, and based on the small criteria that I know, I think it's this. Then the algorithm will see if it's correct or if it's not correct. And like based on what it learned from that iteration, it will take whatever it learned and try it out in the second observation. And then it will try it out in the third observation, all the way to number 80, which would be your final observation. And by the time you're at 80, you should be a lot smarter than what you were at the first observation.
Okay, so I'm thinking of when we did the bulls and cows program back when we did that. We were like the training because each number we guessed with each time we did it, each iteration, every time we tried it, we got more information about what this number is. But when the thing then, so I understand that, but the thing that I don't understand then is when you say get it right compared to what? Like what is if there's no example of what you ultimately want, what are you comparing right or wrong
So
to?
there is, right? Like the training data set is comprised of just like the criteria or like some characteristic and the final output. So for example, if we're going back to like my example of like red wine, sorry, the wine classifier, I could be telling you the pH, right, of X, like of the liquid, right? And you know that if the pH is higher than a 5, it's going to be, I have no idea if this is true, right? But like if it's higher than a 5, then you know it's going to be a red wine. If it's lower than a 5, it's going to be a white wine, right? And so the algorithm may start with like this broad idea of it, but it basically starts like with nothing, right? And as it is going, the training data set would contain not only a characteristic, which in our case would be like the pH, but it would also contain if it's a red wine or a white wine or a white wine. And so when I say I'm gonna guess if that the first one is a white wine, I would see if I am correct in my training data set. So like
Okay.
what I mean by getting it right is like you do have that information, right? There are just like two phases to this. The first phase is like you are training to get better, and the second phase is you are testing how good you are. And by you, I mean the algorithm, but I think it's just easier to think of ourselves as, you know?
Okay, that makes sense. Thanks.
Mm-hmm. Yeah. Okay, so I'll probably go over one more question. So spam the chat now with what question everyone wants to have. Okay, we have 2 9s. I will wait 30 more seconds or like 10 more seconds. 9, 9. Okay, seems like 9 is a winner. Um, so it says which list will be referenced by the variable s after the execution of the following code. So if I have this, basically we have a string that is 12-4-18 dot split by the backslash. Any guesses as to what this one will be? A, somebody saying A, anyone else? Yeah, so the answer for this one would be A. And so if you guys remember, dot split, what it basically does is that it will split by whatever it says in here into a list. So you always want to remember that dot split will basically give you back a list. And so by that knowledge, we know that it cannot be D or E. And then we know that it splits it by this, so it should not include it. So we know that it cannot be C. And then after that, this is a string, right? So we can't just go from a string to all of a sudden an integer out of nowhere. So yes, the correct answer should be A. Are there any questions? And yeah, this question is from the parking ticket project, which I believe not everyone had, but if you're in finance, that's where that is from. If you are in humanities, I think this was also probably helpful for your like, I don't know what the actual homework was called, but like the Agatha Christie paragraph stuff. Yeah, are there any other questions about this one? Cool, so spam the chat with the next question. We have one with 10, anyone else? Okay, so we have 2 10s, which is enough for me. So now we have what would the value variable list A after the execution of the following code? So here we have list A is equal to 632, and then we're saying list B is equal to sorted list A. So if you have looked at the slides that were posted about the review, if you all remember, sorted is a function which returns a new list that is sorted. So if we feed this list into sorted, this is going to give us back a sorted list, which should look like 2, 3, 6. But then I am saying list of 0 is equal to 5. So any guesses as to what the correct answer of this should be?
A.
Yeah. So the correct answer for this one should be A, because sorted returned a different sorted returns like a completely new list, and so there is no tie between list A. Or I guess like it's not even asking for list B, so I don't even know why I'm concerned with list B. You could honestly literally ignore. I guess the important part to remember is that list A is not the one being sorted. List B is the one being sorted. So if you were to change this, then you're just basically changing it with the 6. Any other questions?
So if it had asked like for what the value of list B is, it would just still be 236.
Yeah, if it asked for what the value of list B would be, it would be 236. It would be the sorted version of list A.
Okay.
Can you sort list A using a method? Yeah, you can. You can do list A dot sort. But you knew this because you were in my review. But yeah, you can use it. You could just do list A dot sort.
And in that case, the list A would change, right?
Yeah,
Like-
in that case, list A would change. So for example, if we did, I guess like it wouldn't matter for the sake of list B because we are using the sorted function, and so this returns a brand new list. But let's say that B was not there, and we did list A dot sort before we ran this part. Then our list sorted would be 236, and when I say list of A at 0 is equal to 5, then it would be 5, 3, 6.
That's B.
Yes, but like that is like a different scenario, right? Like the correct answer for this specific one would be A. Again, I think this is a perfect problem to play around with. I would honestly like put this into like a Jupyter notebook or Spider and just play around with like sort of outputs that are going to surprise you. And I really do think that like just playing around in the terminal is like a great way to really challenge like how much you know about this stuff. Yeah. Okay, so let's do one more question. Spam the chat with preferences. I think so we went over 10, we went over 9, 8, 7, 6, 5. Surprised nobody asked about like 3 or 2. Well, I guess there's 1, 2. Okay, 4 seems to have 1 though. So it says, suppose a function f includes the following in its definition. What is the minimum number of arguments required when calling the function? Any guesses? This is our function.
1.
1.
Yeah, so it would be 1. Because 1, so this is our function, right? Here we have a positional argument / parameter, and here we have a keyword parameter / like a default parameter, right? So if we do not give this function when we run it a value here, then n will automatically be 1 and it will not be bothered and it will be totally fine. So I can run this function with just the parameter, with a single parameter. And so the correct answer for this would be B. Any other questions?
Can we do 2?
Yes, I will do 2 and we will call it a day. So now it says the purpose of the parameter p in the partial function definition below is, and so we are looking at p, right? So the first one is to store a third positional argument in the function call. So what type of argument is this?
Positional.
Variable length positional.
Yeah, so it is positional, but it's a variable length positional. I love these questions because I have to think so hard about what I'm about to say because they're just so long. So the first question says, or the first A says to store the third positional argument in a function. So we see the word positional, and so Sure, let's give it the benefit of the doubt, yeah? So for this one, we see the word positional, so we're gonna give it the benefit of the doubt. We see the word positional, we're gonna give it the benefit of the doubt. And then down here, we see store a keyword argument. We know that that cannot be it because this is a variable length positional. And we know that it cannot be E because this is a variable length positional, right? So we're looking for the keyword positional. Now, we have the options A, B, and C. And so let's start reading. So A says to store the third positional argument in a function call. So it is not totally wrong, but because it is a variable length, we not only do we want to store the third positional argument, we want to store everything that comes, right? Whatever this length is. So, sounds kind of right, but not totally right? So let's go on to the next one. B says to store all positional arguments in a function call. So why would this one not be it?
Because of M and N.
Exactly, yeah. So this could not be it because M and N are also positional arguments. And so that is not right. And then the next one says to store all positional arguments, not including M or N, in a function. And so this would be the correct answer because, again, it is a variable length positional argument, which means that it's going to store all the positional arguments that come after M and N.
I'm sorry, can you explain why A would be wrong, please?
Yeah, so A would be wrong because P is a variable length argument. So what variable length means is that this, if you guys remember, we said that if it has one star, that's going to be a tuple, right? So it's going to store all the values inside of a tuple. But what I mean by all the values is that anything sandwiched in between, anything that is like basically from the third position to a keyword will be stored inside of P. So the issue with A is that it wouldn't just store the third positional argument, it would store all the positional arguments until I hit all the positional arguments from the third position to when I hit a keyword. Does that make sense? So I can type it up super quick. So here,
So Q is keyword because it has two asterisks, or is it because a dictionary needs necessarily a keyword because it needs an index?
It's a keyword because of, I guess like both. It's a keyword because when you have a double star, that is like a variable length keyword parameter. But also because like if we don't have a keyword, then we can't store it as a dictionary, right? We wouldn't have like a pair. So print, so for example, here I'm just gonna print P for you all. And so when I run test function here, this is what I mean by it grabs all the arguments. So if I did this is 1, this is 2, and then I'm gonna do 3, 3, 3, 3, 3. And I'm just gonna leave the other one empty, which I mean I can do that. Then you'll see that basically what happens is that this will belong to M because of its position. This will belong to N because of its position. And then all these will belong to P because we never saw a keyword. So if I all of a sudden see a keyword, hello, then you will see that it now starts storing it inside of my queue.
Can you put P equals 3, or would that defeat the purpose?
So that will somewhat defeat the purpose, but I think, let's see, yeah, so it would not work. I mean, I guess 1, it would defeat the purpose, and 2, it just wouldn't work because P is like more than one value. I guess the issue is that like it doesn't, you basically put like 3, 3, 3. I guess if you put it at the end, it may work. Just kidding. Oh wait, let's see. yeah, so if you put it at the end, it will work, but like it doesn't, I don't know. It's like a weird example.
But like if you don't have the other threes, would
Oh,
it
I see.
count?
So if you do it like this,
Would it count? Would it count as a queue?
no, so that would count as a queue, but has because it like has a keyword.
That a keyword.
Thanks.
Yeah. So I guess like the super important thing to remember here is know the difference between positional and keyword parameters, and know that like variable length positional are going to be tuples, and variable length keywords are going to be dictionaries. And then from there, know that I can set these as default values. So in my review, I went over these as like default parameters, which I think if you Google them online, that is also another name that they use. But yeah, those are like the main ideas of it. Any last questions before we go?
About the last review.
So since P and Q are,
Sorry,
Go
go
ahead.
ahead. Sorry. Oh, so someone just go.
I guess I can go. So since P and Q are like multiple values, you would not be able to set like a default value for them, right? Like we do for M in this example.
Yeah, so you wouldn't be, I mean, I guess in this example, it's not good that I set it up there. But yeah, in this case, you would not be able to set up a value because it's like we are going to get multiple values for it. Actually, let's
Okay.
find out. That's a good, I believe no. But let's make sure. I don't think I've ever had to do this either, but yeah, you can't do that. And I think
Okay.
the reason why you can't do that is because it's expecting several values.
Okay, makes sense. Thank you.
Yeah.
I was going
Okay.
to ask if you were able to upload the test review session 1 onto Courseworks.
Yeah, it's up. So I wasn't able to upload it to Courseworks, but I uploaded a link in Piazza to a YouTube video because it was like a 2-hour review. I also got a good amount of stuff from it because I think we went over a lot of things that I think might be more confusing than not, because I think it was like a bunch of questions, which was really good. Yeah, it is up on YouTube. Yeah, thank you. Edna just put the link on there, so it's on there. I also uploaded the slides. I made a new I made a new folder under files called Test2 Resources. So I was planning to put the videos in there, but it was too big to upload to Canvas. So in there are the sample questions, the slides that I used Friday, and an extra video on parameters, just because parameters are something. Yeah, so check them out. Are there any other questions? Cool. So if I don't see you all, good luck on your test. You guys will do great. If you all have any other questions, make sure you post them on Piazza. Yeah.
Thank you.